working. So what we're going to do this week, all right? So the next two sections that we're going to do are probably two of the more difficult ones that we do. And it's not that they're super hard, it's just weird, okay? So we're going to take 2 days to do each of those. So we'll do the lesson today, we'll do some extra practice tomorrow. We'll do the lesson on Wednesday, we'll do some extra practice on Thursday. And then on Friday, we'll do an activity that kind of just pulls it all together. All right, so that's kind of like what we're going to do this week. And then next week, we have 2 more sections to do, and we'll do those Monday and Tuesday. And then we'll do some review and all that good stuff, and then we'll have a quiz at the end of the week before we go on Thanksgiving break. Okay, so also the good news, there are several of you that missed Friday's quiz, and so you should have time tomorrow, like after we finish your practice, that you could do your quiz, make that up, so if you were out. So you'll have time to get that done. Okay, so just know that that's what we're doing. So I left that on the board so we'd have it. Okay, so just kind of a heads up for where we're going. And then when we get back, we'll do the few things we have to do out of chapter 7, and we're done. All right, after Thanksgiving. So we've got about, this week, next week, so 4 sections over the next 2 weeks, just because they're a little more difficult. And then out of chapter 7, I think we do 5 or 6, and then we're done. All right, and we'll have our exam. We'll talk about exemptions and all that good stuff. All right. So that's where we are and what we're doing. All right, remember, if you've not turned in your notes, attend your exemptions based on your grade and the unexcused absences you have. So be sure you've got your notes turned in to the office to take care of that, and we'll go from there. Okay. All right, it's going to be 70 by Friday, so we'll all be sick. Yeah, because it's 0 today, and then it'll be 70, and we'll all be like, what are we doing? Okay, so anyway. All right, so let's get back into, we've been talking about probability, and we're still going to talk about probability in the rest of this unit. And then we won't talk about probability anymore, and I'll be glad, because it's my least favorite thing. Okay, so I'm just be honest with you, I don't like probability that much. But one of the things we talked about were how do we know that things were independent? Does anybody remember? What did we mean for something to be independent? Yeah, does it cause something else to happen? Okay. So it doesn't cause anything else to happen. So we looked at a couple of probabilities. We said the probability of A had to be equal to the probability of A given B, and it had to equal the probability of A given not B. All right, so there were those 3 probabilities that we looked at. What did we call these 2 probabilities that had that bar in there that had a special name? Does anybody remember what they were called? It started with a C. It's all right. It's referred to as a conditional probability. Pencil sharpener. I thought for a minute it was raining. It's okay. I'm getting old. My ears aren't as good as they used to be. All right. We refer to that as a conditional probability. Remember, conditional probability limits our sample size. So we're not talking about the whole group. We're talking about just a part of that group. Okay. And so we're still going to kind of look at some of that kind of stuff today. So our probability today that we're going to talk about are probabilities that occur over a sequence of time. Right? So we're going to use what's called the general multiplication rule, which means we're going to multiply today. Hint, hint, wink, wink, nudge, nudge, right? I'm so glad they named it, obviously, multiplication. We're going to multiply. We're going to create something called a tree diagram, and that's, I'll be honest with you, something that I had never seen until I did statistics, okay? So a tree diagram, and then calculate probabilities using that tree diagram. So that's what we're going to look at. Still talking about a conditional probability, but then the tree diagram will be the brand new thing that we've never seen before, okay? So to do that, we're going to play a little card game. Now, I noticed y'all were looking at my redneck cards that are on your table, those index cards. All right, it's because I couldn't afford a bunch of decks of cards, so I made my own. All right, and so here's what we're going to do. We're going to play a little game. Everybody's going to play, and, somebody gets to be the dealer or hold the cards at the table. But everybody at your table is going to play. And here's how it works. You'll have 5 cards there on your table. All right. You have, where's my other cards? Oh, there they are. I was like, where'd they go? All right. So you have 2 aces. So there should be 2 that have A's on them, and 3 that have K's on them. Okay. So aces and kings. That's how I represented that. Okay. Really redneck. All right, but the index cards were free. All right, and so what we're going to do is we're going to shuffle them up. And then we're gonna ask somebody to draw a card and then draw another card. And here's how you win. You win if you draw a matching set. Okay, so you can only draw one at a time. Are you ready, Eddie? Okay, don't try to look through the cards. Don't you do it. Just pick two. Pick one. This one? Okay, what'd you get? You got an ace. All right, in order to win, you gotta pick the other ace. That, I saw you trying to cheat. Yeah, pick one. Oh my gosh, what'd you get? I got a king, he didn't win, okay? So on your sheet, if you look right there, okay? So Eddie's gonna do this 10 times, okay? You write down your first card, you just put A, and then K for king gives you win or not. Okay, so that's all you're gonna do. You're gonna do that till everybody at the group's taking words, until everybody at the table's done it, okay? So that's how that works. Got it good? All right, let's collect some data. You can decide who goes first. All right, who's gonna hold the cards? And who's gonna choose them? All right, but everybody's gotta choose. I'm gonna put my data up here because I'm not very good. No, she writes her own. You write your own. So like when he's drawing, he's gonna write it on his paper. Okay, when you draw, you write it on your paper. Hey, want me to use?
You got a what? You need the other one.
There he is.
Guess that was really difficult one.
Alright, yeah,
How many times do we go there?
Okay.
So are we gonna do like well, you just shuffle the cards and then someone like grabs the card and then you shuffle it again. You start getting another card. And if they're not the same, you lose it. You just write down your information. Like I got HA and then that's my number and then.
Is it? I think it. Some of y'all cannot go to get a lottery ticket today.
That's literally why I'm
Go
try that. She's ready when I'm ready.
No, I haven't even started. That was bad. Oh, you won?
Okay, one more time.
Go away.
Got an ace, okay. Means I need to find an ace. Wait, he put him, what did he put him at the side? Yes. I have no idea what's going on.
Where do you work at?
You have to pick the other ace.
Oh,
They were excited. Give me just knock him out, so you don't have to get enough. Alright.
I had to do highlighters so that it would show.
What's too lazy?
as you should know, you know, like you're not trying to.
Maybe one day I'll do it.
Yeah.
I'll take the guy we got one more time.
Here's like a little bit of spark.
You have.
You can see it. Oh, yeah, I can see it. Thank you for pointing that out. We're gonna keep going. Technically, we don't have to. Oh, he's only reporting his responses. You're supposed to report everybody. Everybody?
Just put them random.
I heard that list. 3 more? Okay.
And what's your real name?
There you go.
What's your real name? Valdez? Valdez? You get them? He has down that he won every single round.
Oh!
That's perfect. Reese's Cup?
Has anybody won more than 5 times? Oh! Oh! Okay. I know he's making a lottery number. Here, you got it.
Tell me they win more than that.
Oh, we? I did, oh.
Yeah.
No, all I need to do is knock down.
I hate voting for this, bro. I hate for this.
Cause I'm gonna find. I don't have. I thought I was
No, like, you have no big friends, no big pay.
Are you drunk?
Oh!
Are you drunk?
Alright, go ahead.
Sorry guys, I'm broke. I don't want to. That's really all I need.
Do you use your notes? Do you use your notes? I don't even take notes.
Right.
That's something that sounds like to the air.
All right, you're done. I'm gonna pick up your chamber cards so I don't lose them. I'll have them again next year. Yeah, I only teach 6 months a year, so.
I think Eddie was cheating.
Eddie.
Look at his cheek. You see how many he's won and how many he's lost? He's lost like twice this year.
What are you not doing? Oh. You have to get creative when you don't have a lot of resources. Okay, so here's what I want you to do. Count up your number of yeses. Okay, you played it 10 times, so count up your number of yeses. And then write down your probability for winning based on what you did. So mine would be 3 out of 10. And we'll just leave it as a fraction for right now. We'll mess with that in just a second. Okay. So what we're going to do is we'll come up here, we'll do and we're going to write down our wins. So I was 3 and 7. Okay. So let's start with this side of the room. You'll come up here and put your, I'll leave my put your wins and losses for me. Okay, you don't have to put your name, just your number. We're going to add it all up. So y'all come on this side of the room. Yeah, everybody. All right, middle set. I mean, right, the last set of tables. Put your wins and losses for me. Oh gosh, I'm gonna have to do a bunch of math. Okay, so one of the things it wants us to do is look at this whole class's data and what would be our probability to win, okay? So the first thing I have to do is tally up all our wins, right? So let's see if I can do that math. Oh gosh. All right, 3, 6, 9, 12, 5, 10, 15. That's a 10, 10, 20, 30, 40. Then 2, 4, 6, 8. All right. 102. Woo. Okay. Now, so there's 102. How would I get the total number of games that, like the total? All right. So wins and losses. How would I figure that out? Okay. What kind of math can I do to figure it out? We could do some multiplication. Yep. How many of us are in this room? There are 26 of us in the room. And how many times did we get to do the game? 10. So it'll give me 260 total games that were played. Okay? So our probability based on that, so we got our total and we got our number of wins. Okay, so for us as a group, okay, it would be 102 out of 260. Okay, so that's how many wins we had, right? Let's get a decimal for that just so that I know kind of what it represents. 102 out of 260 doesn't mean a lot to me. A decimal might help me. So about 39%, so about 0.39 or 39%. So that makes a little more sense to me what's, in terms of the percentage that we won, okay? So what I want to do is I want to walk you through a tree diagram. This is what we call a series of outcomes, okay? I had to draw one card, and then I had to draw another card to determine if I won. So I had to do multiple things. And so when we do that, that's when a tree diagram is really useful. So in the ACE game, all right, we had a couple of options. All right, we could get an ace. So if we look at how this tree is drawn out, it says the first card's an ace, the second card's an ace, all those kind of things. And so how many aces were in my pile when we started? 2 out of 5. Okay, so there were 2 out of 5 of my 5 cards were an ace. Okay, so that was my probability of an ace just before we even did anything. And how many were a king? Okay, there were 3 out of 5 that were a king. So when we talk about this, we have the probability of an ace or the probability of not an ace. So that's where you would see that A with a C. Okay, so that's how when we start, we look at what did we have when we started. Okay, now once I start this process, okay, we're going to talk about all the different scenarios that could happen. Okay, so I've got my cards, and the first card that I pull out okay, is an ace. I set it aside. I can't pick it anymore. How many cards are now left? 4. How many of them have an ace on it? 1 of them. So the probability, okay, that we're going to get an ace is 1 out of 4 because that's all I had left. Okay, I only had 1 ace out of my 4 cards that are left. How many kings did I have left? I had 3, right? I had these 3 kings that were left. So 3 out of 4. Okay. I had 3 out of 4. Now, what's cool about a tree diagram? Okay, it's going to populate in a second. Give it a minute. There it is. Okay. What's nice about a tree diagram is that it allows me to do the sequence of events. When I start, I have a 2 out of 5 chance to get an ace. So my first card is an ace. It's 1 out of 4. Well, how do I get this probability over here? It's really easy. We multiply. Okay, we follow the tree and we multiply. So I would multiply 2/5 times 1/4. Okay, that would give me 2 over 20. So I'm just going to leave it like that. Okay, so we just multiply. All right, we follow the tree. And we multiply. So I went that way, and then I got that probability. Okay? To get the probability underneath it, we're going to do the same thing. Okay? So we're going to take what we started with, 2/5, times my options to get a king, which was 3/4. Right? And so that would give me 6 out of 20. And I literally just follow the tree. Start here. I then follow that branch, right? And I multiply those probabilities. Okay? Now, let's go the opposite end of the tree, all right? So let's say that the first card that I draw is not the ace, it's one of the kings, okay? So how many cards do I have left when I do that? I still have 4 left, okay? I have 4 left. And so if I have 4 left, how many of those 4 are my aces? 2 of them. Okay. And how many of those 4 are my kings? 2 of them. Okay. And so to get that combined probability, again, we're just going to follow the tree. Right? So we would start 3/5 times 2/4, and that would give me 6 out of 20. So I follow the branch. All right, I start here, I go there, and I just take those individual probabilities. It's where they come from. We're multiplying them. And then we do the last one, 3/5 times 2/4. We get 6 out of 20. So again, following that branch. Start here and then go to the bottom one. Okay. Now, what's interesting about this chart? Okay. I want you to take a second and look at this first set. All right. I have 2/5 and 3/5. If I add that together, what would I get? What's 2 plus 3? 5, and what's my denominator? 5, okay? It adds up. 2 plus 3 gives me 5, okay? So those probabilities match each other. In other words, they add up to 1. If I look at this next set, so just the 2 right here, okay? So on this next branch, 1/4 and 3/4 gives me 4/4. If I go down here, this branch, 2/4 and 2/4, it gives me 4/4. It gives me 1. Now, what's interesting are these final probabilities. 2 plus 6 is definitely not 20, right? But 2 plus 6 is 8, plus 6 is 14, plus 6 is 20. So if I add all of those in that last branch, it should equal 1. So here's a good way to look at this in terms of checking yourself, getting your probabilities correct, right? This first set, okay, both of them together add to 1. Okay. The second set, we do them in individual groups. Okay, so the top branches and the bottom branches, add to 1. And then on the last one, all of the branches, okay, add to 1. So it's everyone. So it's only in the middle that we split it into 2 groups. Okay, so we can check it that way. Now, I want to talk to you about this last little piece that we have here that we can do. How do we do conditional probability from this, or how do we do theoretical probability? It says find the theoretical probability of winning the game. Tell me again, how did we win? What were the things we had to do to win? We either had to get 2 aces or we had to get 2 kings, right? It was one or the other. So to get 2 aces, so that's an ace and an ace, all right? There's this probability, 2 out of 20. Okay. To get a king and a king, this is this branch. It's 6 out of 20, and we're just going to add those together. All right, which will be 8 out of 20. What's my decimal for that? .4? Okay. All right, so there's that probability. Now, I want to look at this last one because I think this is interesting. It says, what's the probability that the first card was a king given that we won the game? Okay, so the first card was a king given that we won the game. So remember, this is that probability that we talk about. So king given that we won. Okay, so I guess we should say first king given that we won. Well, we just did the probability that we were going to win this game. Okay, what was that probability that we were going to win this game? Right, it was 0.4. Okay, so that was my probability that I was going to win this game. Now, the next thing we have to do is do the probability that my first card was a king. Okay, that my first card was a king. Right. Well, if we look, okay, in terms of our winning, okay, so I only have 2 places I can pull this probability from. I can pull it from the top because that's a winner, or I can pull it from the bottom one because that's a winner. Which one of those 2 options has the king first? The top one or the bottom one? The bottom one. Okay, so get me a decimal for 6 out of 20. 0.3. Okay, it's 0.3. All right, so I had to pick it. When you do conditional, okay, you can only pull your top number from one of the 2 things or one of the 3 things or wherever you got your original probability. And so if you divide all of that, you would get 0.75. So the probability that you would get a king first if you actually won was about 0.75. Okay, so do you see what I mean by this is a little more complicated than what we've done so far? There's just a lot more to it, okay? This 0.3 from 6 out of 20, because I could either take the 2 out of 20 because that was a winner, or I could take the 6 out of 20. Well, the only one that had a king first was the 6 out of 20. Yeah, and 6 out of 20 was 0.3. Okay, good question. Right. Now, let's just kind of organize our thoughts on this because there's not a lot of really different ways to do it, okay? And it's really weird, all right? It's really weird. So I want to just kind of walk you through the chart, all right? Typically, we have 2 events. Sometimes you'll have 3 events and things that we have to do. But the thing to remember is with that multiplication rule, you're going to follow the branches and multiply, okay? That's what we do. We follow the branches and multiply. If things are a sequence of outcomes, things that could change along the way, we're going to multiply, okay? So, our general multiplication rule, right? Let me give you the the math, and then I'm going to show you what I actually do. Okay, so it's the probability of the first event times the probability of the second event given that it's part of the first group. Now that's weird to remember, okay? So probability of the given A. All I would tell you to do is this, we use this for a sequence of events. And it just means we multiply those probabilities, okay? Multiply probabilities.
Four.
Yes.
I have David Ortiz for dismissal.
Yes, sir. Peace out, Boy Scout. Okay. Now, for your tree diagram, okay, we're going to start with two things. All right. So the first one is the probability of this event. The second one is the other option, not that event. Okay. Okay. And then that's going to split into two events. Okay. It's going to split into two events. Right, that we'll refer to as B and C. See you, bye. Okay. And then the bottom one is going to split into those same events. Okay. We're going to use our probabilities. Okay, we multiply the probabilities. Now, that doesn't make a lot of sense just looking at that diagram. I think it makes much more sense when we take a situation and we throw it in there. Okay, so I want to kind of walk you through several examples of this because I think it'll help you. Okay. So we're basically just going to split things around. In fact, this one splits 3 times, and then those 3 split into the same 2. So it gets really a lot of stuff going on. Okay. The main thing to remember is when you're doing your probabilities, right, your sequential ones, we multiply. All right. Okay, so let's look at this actual application down here. Okay, so it says lactose intolerance causes difficulty in digesting dairy products that contain lactose, right, which is milk sugar. It's particularly common among people of African and Asian ancestry. In the United States, not including other groups and people who consider themselves to belong to more than one race, 82% of the population is white, 14% is black, and 4% is Asian. Okay? Then it goes over to say that 15% of whites, 70% of blacks, and 90% of Asians are lactose intolerant. Okay? And so we're going to select a U.S. person at random. So when we set this up, okay, we're talking about the people, right? And we divided our people into 3 groups. What were the 3 groups? Yep. Okay. We divided them into their race. So white, black, Asian. Right? And then each one of those groups, we split into, are they lactose intolerant or not? Okay, so a yes or a no, basically. Okay, so we split them into a yes and a no, each group. Yes, I can drink milk. No, I cannot. Okay, so this is their lactose intolerance. All right, now, what makes this challenging is when we look at this information they gave me, it's all in percentages. Okay, so we're going to make it all decimals. Right, so 82% would be 0.82, 14% 0.14. So we're going to use decimals. Let's start with information they gave me about the population. Okay, what percentage of our population did they tell me was white? 82, so I've got a 0.82. Okay. Then they told me that my population that was black was 0.14 and Asian was 4%. What would that one be as a decimal? 0.04. Okay? Now, those three numbers should add up to 1. Okay? Anybody want to double check it? Just be sure. Okay? 0.82, 0.14, 0.04. It should add up to 1. All right? That should be 100% of the people that I'm talking about. Okay? Now, we're talking about them being lactose intolerant. So, yes, I'm lactose intolerant. No, I'm not. So, let's take a look at what they told me. They told me that 15% of our whites were. So, that, yes, would be 0.15. Okay? 70% of our blacks were lactose intolerant. So, 0.70. 90% of our Asians, 0.90. Okay? Now, we have to make sure that each section adds up to 100 because I can't be yes and no. I'm either yes or I'm no. All right? So how do you suggest that we get the no percentages for each group? Subtract from 1. Okay? So to get my no group, all right, I'm going to do 1 minus 0.15. Okay? So subtract from 1. All right? So get your missing numbers. Subtract from 1. Okay, so we want to subtract from 1. So 0.15 minus 1, that would give me 0.85. Okay. 1 minus 0.7, that would give me 0.30. 1 minus 0.9 would give me 0.10. So the first part is setting up the chart. So let me stop there. Okay. What question do you have about setting up the chart? They're going to always give you enough information to fill in at least parts of the yes-no pieces. Okay? You'll have to do a little subtraction to get what you're missing. Okay? What do we think? All right. So now let's look at the next part. Okay? The next part says to find the probability that our person is lactose intolerant. Does it care what race they are? No. Okay? It didn't say a specific race. It said how many people are lactose intolerant. So we're going to actually do 3 probabilities and add them together. Okay? So to make that happen, we're going to follow the chart. Okay? For the yeses. So we would start with this first person is white and lactose intolerant. They are black and lactose intolerant. They are Asian and lactose intolerant. Okay, so we're going to have 3 different probabilities that we're going to add together. So the first one, I would take 0.82 times 0.15. Okay, the second branch of the chart, 0.14 times 0.70. And the third branch of the chart, 0.04 times 0.9. So we're going to do a lot of math in that regard. Okay, so you're going to follow your branches. You multiply on the tree. You add them up in the end. Okay, how many different groups were we talking about? 3 different groups that could be lactose intolerant. All right. So I think that will give you 0.257 when you do all that math. Okay, I'll do that arithmetic for you. Right? So we multiply across the branches, and then we add up all the branches that meet our qualification. Okay? So, can we create the chart? Do we know to multiply when we're talking about the chart? And then if we want our probabilities, we might have to add them because there might be several. Okay? Let's look at this last one. It, too, is a probability. So it says, given that the chosen person is lactose intolerant, what is the probability that he or she is Asian? Okay? So I want the probability that I am Asian given that I am a yes, basically. I am lactose intolerant. Well, the good news is I've already done that yes group. Okay? We did it in the problem above. It's going to be my denominator. So that's going to be that 0.257. Right? But this time, I don't want all 3 of those branches. I only want one specific branch. Which branch did I want? The Asian branch, okay? So the Asian branch is the only one I want. So I take just that Asian branch, okay? So on the top, I do 0.04 times 0.90, okay? You're going to want to do that multiplication on top first and then divide, okay? So 0.04 times 0.9 gives you a 0.036 and divide it by that 0.257. Okay, so you'd have a 0.141 chance, right, of meeting that probability. Okay, so what I want to do is show you a couple more things, okay, because this is weird. It's a different kind of math than what we've done, right? This is the hardest probability we do, okay, is with this chart. It's also why I didn't put it in with that other stuff we've been doing. I kept it separate, all right? So I do want to look at these next few examples, all right? Not all of them, but just to get us started, okay? Make sure we can set it up, all right? Not always will we need to draw a chart, okay? So let me show you this one. So this is based on a March 2018 report by the American Academy of Children and Adolescent Psychiatry. 90% of teens ages 13 to 17 use social media. Of those teens, 83% have at least one active social media profile. Find the probability that a randomly selected teen uses social media and has at least one active profile, okay? The good news here is they gave me both the probabilities that I needed, okay? And they are sequential things, all right? So, randomly selected teen uses social media. How many randomly selected teens use social media? Okay, so there's my first probability. 90%, it would be 0.9. Okay, the next sequential event is they have at least one active social media profile, which they do. That's 0.83. So we're just going to multiply them. Okay, so that one doesn't need a chart. It doesn't need the yes, no, and all this stuff. Okay, they gave me the two probabilities in question. All I need to do is multiply them together. Okay, they are two things that are sequential in nature. And so that would give me, I think, 0.747. Okay, so we're going to like it when one like that shows up. All right, and we don't have to do the tree. Right. Okay. Well, let's look at this next one. This next one does involve the tree, so I just want us to be sure we can set it up, okay, because that's the hard part. They'll have one where you kind of have to drag and drop, and then they'll have one where you'll kind of have to draw it yourself and use it to get your probabilities, okay? So who likes pop music? So Spotify revealed that about 40% of its users are age 13 to 24, 25% are 25 to 34, and 28% are 35 or older, okay? So we're thinking about what are our different groups that we're dealing with, okay? So we've got a person, and we split them into three groups, okay? So I'm going to put their ages right here. We had 13 to 24. We had 25 to 34. Oh, y'all, I'm in the top group. 35 plus. Okay? So that's the first thing it told me. Did it give me percentages for all of those groups? Sure did, so I'm going to record them. All right, 47% are in that first group, so 0.47. 25%, 0.25 are in the second group. And 28%, so 0.28 are in that third group. All right. Then it goes on to tell me, all right, what their favorite genre is, okay? Who liked pop, all right? So it was either pop or not, basically, is what we had, okay? So a yes or a no. We liked pop or we didn't. So pop or not, okay? Pop or not. So So you have to look at what becomes the yes, no part, okay? What is it that we're saying we can do? We can do pop or we like pop or not, okay? So now let's fill in those percentages that they gave me, okay? So for the 13 to 24, 85% said it was, so that's a 0.85, okay? In the next group, 59% said it was, so 0.59. And then the last group, 23% said pop was their favorite, right? We still need to fill in those other branches that we can't see, all right? Well, that's where we have to do the subtraction, okay? So 1 minus 0.85, that gives me a naught of 0.15, okay? 1 minus 0.59, that's going to give me a naught of 0.41. Did that math in my head. Okay. And then 1 minus that 0.23 would give me a naught of 0.77. Right? So that's drawing the tree. Okay. All right, and then the last thing, find the probability that their user's favorite music genre is pop. So we want all the people who want pop, okay? We don't care what group they came out of. They're the ones we want. You're the one that I want. All right, so we're going to go each age group and multiply, okay? Because I have 3 different age groups, I'm going to have 3 different probabilities that we add together in the end. So I would take my 0.47 times 0.85 plus 0.25 times 0.59. So we're just going to multiply a bunch of decimals. 0.28 times 0.23. Okay, and that would give you your final probability. Okay. I believe it's 0.6114. Okay. Now, just because I don't want to take time to do another chart, all right, let's say I added a question on here, all right, and I wanted the probability, okay, that they were in that middle age group given that they liked pop. Okay, so let's do that conditional probability. Okay, when we do that conditional probability, all right, it's always a fraction. The denominator is that second thing. It's going to be the amount of people that liked pop. Well, we did that already. It's right here. Okay, it's that 0.6114, so it's going to go in the denominator. Okay, what numbers are we going to use to figure out the probability of just that middle group? It's got to be one of those branches we highlighted. So which branch will it be? Yep, the 0.25 and the 0.59. We're going to multiply those. So 0.25 and 0.59. It has to be part of something you already did, okay, since it's all the yeses. All right, and I don't have that number in front of me because I just made it up. 0.25 times 0.59 gives me 0.1475, and then I'll divide that by 0.6114. .2412. Okay, so today you have 3 problems, all right, because it's a lot, it's hard, okay? So I want us to do that. Tomorrow we're going to amp that up and we're going to do about 10, but we have all class to get them right and be sure we feel good about them, okay? So today, let's see what we can do with those 3, all right? And it should be open. There's computers over here if you need one, all right? And we'll go tinkle at the same time. We'll kind of do it all right? There you go.